Results on periodic function. These results are very important for every exam asked for higher mathematics. First result is if fx has fundamental period t, then period of fax t upon mod a, because a can be either negative or positive, so period is always positive. You can mention here t is greater than 0. Second is linear combination of periodic function may not be periodic. Means LC, linear combination of periodic functions may not be periodic. That is linear combination C1 fx plus C2 gx may or may not be. These two condition is by this terminology. For example, consider fx equal to cos x and gx, consider pi x, and we know that graph of cos is repeat after 2 pi. It means period is 2 pi and here 2, but fx plus gx is not periodic. Composition. As we define Fogoff, composition of two non-periodic, if non-periodic, function can be periodic. Remember this point. If non-periodic, then can be periodic. If periodic, composition of two periodic function can be non-periodic. Means two results in one non-constant function. Second point is non-constant function never be periodic. Now a very important result, and this is by generalizing you can, if f is a periodic function and defined from R to R, continuous plus periodic. I already say if f is continuous and period is t, and we know that period is always greater than 0, then f is bounded. Means image of f is nothing but f 0t. You can analyze this by sine function. Graph of this is like that, and we know that sine function repeat value after 2 pi. It is continuous. So first property is defined on continuous, and second is all value will repeat after period. Then value will repeat if this is periodic, otherwise value will not repeat. So after certain height, function will behave like as previous one. So all value, you can say this value is repeat after period. So image of all domain point is image of first period or anyone, means 0 to t, if this function is defining from starting point is 0. And one question is this one: suppose f is a function continuous and satisfying this property for all x belongs to R, then f is not necessarily bounded above. So you can mention point here. If function is bounded and continuous, also periodic, then it will attain suprema as well as infima. And this suprema and infima value before first period, or you can say means after the value is repeating. So you can generalize for sine function. This is suprema and is coming between this one, and this is infima because function is bounded. So suprema and infima will exist. It means function is bounded. So by this property, f is not necessarily bounded above. It is wrong option for this question.